Good day, everyone. I'm Ilesanmi presenting on behalf of Owofadeju and Ilesanmi, Department of Wood Product Engineering, Faculty of Technology, University of Ibadan. A paper titled Efficacy of Oil Extracts from Sweet Orange, Citrus Sinensis, Peels and Seed as a Natural Wood Preservative. Most of the synthetic preservatives used in the treatment of wood are toxic, carcinogenic, and non-degradable. Examples of these preservatives are CCA, borates, creosote, and so on. There is a need to find alternative preservative to save our environment. Preservative that is efficient, effective, and environmentally friendly. Sweet orange has been found to possess some antimicrobial and medicinal usefulness due to the active ingredients in it. This study therefore investigated the potential of sweet orange, peel and seed extracts as wood preservative using a non-durable wood, Gmelina arborea, as a test sample. The sweet orange was obtained from Ilefe, Ife local government of Osun State. The tree is of height 5.3 meters and about 23 years of age. It was properly identified at the Department of Botany, University of Ibadan. The seed per orange fruit ranges from 8 to 17. The seeds were properly shelled from the coats and air dry, grinded to increase the surface area. The determination of moisture content was carried out according to this formula. Percentage moisture content W2 minus W1 over W1 times 100. W1 was the initial weight and W2 final weight. Extraction process of oil extracts. A 500 ml sourceless extractor was used for the extraction of the oil at Central Laboratory, University of Ibadan. The year samples of orange, bark and seed were grinded to increase the surface area. A weighed quantity, 100 grams of grinded sample were packed in a Wattman filter paper. The solvent N-hexane was used as an extracting solvent. The extractor operated at a temperature of 60 degrees centigrade for a period of 16 hours. The oil was concentrated at 200% using rotary evaporator. The rotary evaporator operated at a temperature of 65 degrees centigrade. Percentage yield was determined by this formula: weight of the sample residue over weight of sample before extraction times 100. Preparation of wood samples. The wood species used was Gmelina arborea, as said earlier on. The wood was bought at Songo Wood Plank Market, Ibadan, Oyo State, taken to Federal Research Institute of Nigeria for proper identification at the Department of Forest Product Development and Utilization, and it was processed. The process involved cutting, planing, and also dimensioning. The wood samples was properly planed and cut to dimension 2 cm by 2 cm by 6 mm. The determination of moisture content of Gmelina arborea was carried out as earlier mentioned procedure for citrus sinensis. We weigh before and final weigh after oven dry, and we apply the formula initial minus final over final times 100/1. Preparation of preservative concentration. The volume to volume method was used to dissolve the extract of both the seed and the peel in kerosene. 1 ml of extract in 99 ml of kerosene is equivalent to 1% dilution. Hence, 0%, 25, 50, 75, 100, as well as the control were used for the study. Impregnation of preservative. The wood samples were impregnated with oil extracts through cold soaking for 72 hours for effective penetration of oil extract into the wood at different concentration levels: 0, 25, 50, 75, and 100%. Absorption test. The rate of absorption of the wood samples when immersed in preservative was based on the difference between the weights before and after immersion. Preservative in percentage, W3 minus W2 over W2 times 100. W3 means weight of wood sample after immersion in the preservative. W2 means oven dry weight of wood samples before immersion. Decay test. The wood samples were inoculated with the wood decay fungi, white and brown rods, respectively, in petri dish. The inoculated plates were then incubated at room temperature, and observation on weight loss were made at the end of 12 weeks in accordance to ASTM D141372 test method for solid wood. At the end of incubation, blocks were removed from the test petri dish, and the mycelium was carefully brushed off the samples. The initial and final weights were taken to determine the weight loss. The weight losses were used to determine the effect of fungal inoculation on wood samples. Wood decay was estimated using the formula initial weight minus final weight over initial weight times 100/1 as shown. Results and discussion. The initial moisture content of the citrus sinensis, peel and seed were found to be 60.7% and 57.6% respectively. The peel and the bark were dried below 10%. The oil yield of the peel was 4.1% and the seed yield was 31%. The color of the oil peel was brown and the seed oil was yellow. The result of the percentage oil yield of seed was in line with Nwobi et al. 2006 that reported the oil yield of seed oil to be 36%. However, Madori et al. 2014 reported a yield of 12.3%. The mean value of the absorption rate of preservative was found to be 14.8% 98, the highest value of the absorption of the pea oil extract was 16.7, while the lowest value was 12.25. The mean absorption rate of wood samples in citrus seed oil extract as preservative was found to be 15.1, and citrus extract was found to be 14.87. At 25% level of concentration, the value of absorption rate of seed oil was noted to be 14.73, which is higher than the pea oil extract 12.25 at 100% concentration level. It was observed that wood samples has absorption rate of 14.97, which is lower than absorption in pea oil extract 16.69. You can see it in table 1, mean value and standard deviation of absorption of Gmelina arborea. The preservative concentration, the seed oil, the peel, and the mean value. It was observed that there was a higher weight loss at the control wood sample, untreated wood samples, compared to other concentration levels, which had a mean of 22.75 and lower weight loss 11.75 at wood samples treated with 100% preservative for the seed oil. The mean value observed for brown rot decay fungi is lower, 12.80, compared to that of white rot fungi, 15.97 for the seed oil. 100% preservative of seed oil extract exhibits higher preservative potency compared to 0, 25, 50, 75, and control respectively. Table 2 reflects weight loss variation in wood decay using citrus sinensis seed oil extract as preservative. You can see the concentration of the preservative, the values for the white rot fungi, the values for the brown rot fungi, and the mean value. For the peel oil extract, higher weight loss 21.19 was observed at the control untreated compared to wood samples treated with preservative at different concentration level. 100% preservative treatment is more effective than preservative treatment level as reflected on both fungi, white and brown rot, with mean value of 8.32 and 8.06 respectively. The attack of white rot fungi in respect to percentage weight loss was high compared to brown rot fungi. The range of concentration of orange peel oil extract that display maximum resistance against fungi attack in respect to weight was 75 to 100%. Table 3 shows weight loss variation in wood decay using citrus sinensis pea oil extract as preservative. You can see the preservative concentration in percentage, white rot fungi, we have the brown rot fungi, the values, and the mean value. Conclusion: citrus sinensis seed and pea oil extract shown considerable effectiveness against white rot fungi and brown rot fungi attack on Gmelina arborea wood at varying concentration level. The maximum range of effective concentration level was found to be between 75% to 100% of the orange seed and peel oil extract. However, the level of efficacy as observed from the study was considerably low, with a mean value of 8.19 compared to other plant extracts and synthetic chemical. Thank you for listening.